Hello, and welcome back to the Sustainability in Action broadcast. I'm Alex Dickins, Channel Management Team Lead at DCD, and I'm delighted to be moderating this session, which is sponsored by ZincFive. Now, this session will be taking place as a fireside chat, which will explore the topic choosing sustainable backup power without compromising on safety and reliability. Joining us for this session, we're delighted to introduce Schott, Director of Product Management for ZincFive, and of course, Carsten Baumann, Director of Strategic Initiatives and Solution Architect at Schneider Electric. Gentlemen, welcome.
Thanks for having us.
Welcome. Thank you. It's great being here again.
No, great to have you. So let's get right into it. This year we've been hearing a lot of developments in the market, AI, sustainability continuing to be at the top of people's agendas, challenges for securing backup power. The title, as we've kind of outlined, is looking at sustainable backup power without compromising on safety and reliability. We're hearing a lot in this space, but Aaron, from your perspective at ZincFive, could you explain why we're here today, why we're talking about this?
I think there's just so many new developments in battery technology that everybody's kind of wondering, as we're marching down this road for bigger and bigger data centers, more and more compute power, more UPS power, larger UPSs. There's a lot of questions around what is the right technology and what are the right batteries to go with those technologies to make our data centers more sustainable. I think we talk about over the last couple of years of how much AI is going to impact the physical size of a data center, how much more facilities, more of everything. But we also talk so much about what we need to do as the human race and becoming more sustainable to offset climate change and to make really the data center industry more sustainable, or at least more efficient and greener in its operation. So I think as we look at all these things, everybody's looking at all the different aspects of it, from the type of concrete they use in the facilities to the efficiency of the UPSs and the cooling systems. And battery is a very big topic because everybody's trying to figure out, what are we doing in the industry with these batteries? Are they going to be connected to the grid, for instance, or are they going to be still kind of down the standard path of it attached to the UPS systems? So as we look at that, we want to make sure that that selection of a battery is really the most sustainable it can be. And with me today, Carsten, I always think of Schneider Electric as really the leading bleeding edge of sustainability in the data center movement. And I think with this, I kind of ask the same questions, like what are you guys seeing out there in the sustainability of data centers, and what are your customers kind of looking to? Because as we think about batteries, it's really the whole big picture of sustainability.
Yeah, well, thank you, Aaron, also for inviting me to be on this call here, and me representing Schneider Electric. And I think you're absolutely right. I mean, at Schneider Electric, when I think about sustainability, we've started this journey 15 plus years ago, before it was even called sustainability. And so we have made a lot of progress. And are we there yet? No, we're not. Can we solve it ourselves? No, we all have to collectively work together. But when I think about the data center industry, I mean, right now, I define it as almost we're in the golden age. So there's more and more need for data centers. We can't build them fast enough almost. There's a lot of constraints around us, and as we are consuming collectively more and more energy in these new data center capacities, which, by the way, we estimated that, so by 2040, which is just about another, 16 years away from now, the data center capacity globally will about double. So that means, now we need more energy, and therefore, the focus or the emphasis on creating a more sustainable data center is becoming so critical, because currently, the data center industry, depending on various research studies, consumes somewhere around 2% of the global energy demand. So now when you think about, we want to double this capacity, then all of a sudden, now this becomes a bigger portion. So we have to become really mindful in developing this net zero data center of the future. And I think energy storage is a big component of that. And as we see, criticality for many data centers is of utmost importance. And then therefore, when we look at sustainable on-site power sources, the energy storage itself, in a battery technology is becoming a really critical key component. And what we see from our customers is like, yes, we want to transition away from fossil fuels. And then all of a sudden it opens the door for questions about, okay, so how are we going to do this? I mean, can we do it with hydrogen? Can we do it with small modular reactors? Whatever. So I think there's a transition toward various technologies, and energy storage is becoming a key component. So therefore, battery technology, battery energy storage technology is becoming a big element, and especially when we think about that UPSs these days, don't necessarily exclusively fulfill the requirement for backup power, but of course they do power conditioning in order to ensure that the power quality itself for the IT operations is always there. And then, the attached energy storage, in this case, battery technology, needs to be sustainable, and it serves different functions, perhaps even becoming more grid interactive with utility companies, and therefore the role of battery energy storage in a data center is becoming more critical, more relevant. And as we grow this capacity, I can only see that there's more and more capacity required on those battery energy systems.
Yeah, absolutely. And I think the great thing about working for ZincFive and having a nickel zinc based battery is it is our own sustainable story. Probably 4 years ago, we we thought it was pretty good. So it was like, well, let's hire a company to go in there and look at the all of our climate impact metrics, from our greenhouse gas production, our carbon return purchase, how much water we're using in the manufacturing of batteries, and then how volatile organic compounds or different things in VOCs, that all the different aspects of what sustainability is looking at today. We thought, well, let's see how we compete. So we went through that initiative, and we found out we performed very well and compared to a lot of other battery technologies, from a significant reduction in greenhouse gases compared to both lithium ion and lead acid. And it starts that look at sustainability. Once you know that your battery itself is doing pretty good, you start thinking about, well, how do we make it better? And I think as customers for their data centers are looking at the same thing. If you take every little aspect of the data center itself and break it down into a smaller chunk and think of, well, how can I make this piece better? I think everybody's looking at batteries because it's been a long time of changing it from lead acid to lithium, and now there's a lot of things about out there, is how green is the lithium technology you're using, how sustainable is it, the recyclability stories of different batteries technologies. So having a solution that customers can look at and say, well, this kind of makes sense, because with nickel zinc we have a good climate impact metrics, a good scores versus other competition, but also there's a good recyclability story. Because of having an inherently safe technology, it becomes easy to recycle, and I think that's an important part of that. Is as we look at the data center in a whole, it's you're not just looking at day one, is this product greener, but over the operation of the data center, through the next 20 years or longer. For some, I mean, I've seen a lot of data centers over the years that say they're 15 20 year design life, and 10 years ago I went to the facility and it's the same UPS, the same technology, that it's like that. Wow, that they're lasting longer and longer, and they're trying to get every little bit out of those data centers, so potentially even up to 30 years now. So it's how can we
Yeah.
keep these data centers in operation, and which is actually more sustainable in itself, just keeping a lot of things going as long as the efficiencies are good on the UPS technology.
I have a question for you, Aaron. So you just mentioned, okay, the transition, I mean, VRLA, lead acid batteries, the majority, I think, of new applications right now, they're all leveraging some form of lithium ion battery technology. And then with nickel zinc, you mentioned, I believe there are way more. I mean, when I think about from cradle to grave, this entire life cycle, number one, there are questions around, not questions, but sourcing lithium, one of the key components of lithium ion batteries is one thing. But then when I think about nickel and zinc, I think these are very more abundant available metals, right? So, and then also the recycle process of lithium ion is in a very early stages, infinite stages where we have very little recycling resources globally at this point, and yet, the industry, whether it's the data center industry, but also the transportation industry, banking on so much on lithium-ion batteries. So it really becomes a question about how do we recycle this at the end of life? And so how does nickel zinc fit into this whole kind of like cradle to grave kind of story? I'm kind of curious to know more about it as well.
Well, yeah, and I think that's an interesting part of the whole conversation. That you started out with just the mining processes, and that's where I said that a lot of people have been, they've been migrating to lithium ion, but they're starting to question that industry. There's a lot of conversation out there on, well, how sustainable or how much lithium is there that's easy to mine in itself, and then how is it mined? And then other components that go into those batteries, how are they sourced? And I think from a nickel zinc perspective, again, as you mentioned, nickel and zinc are both very abundant, but they've existed as in the metal industry for hundreds of years. I actually saw a photo recently in where I live in Western Pennsylvania. Right down the street from me was in 1880 was a zinc plant that took zinc out of the local resources and mined it here and made ingots and different things like that. So that industry has been around a long time, but also it's very easy to recycle zinc out of other metals and materials. So you can process nickel and zinc, and they're both valuable metals. So everybody is interested in processing them and recycling them out of the metal, other metals industry, galvanization, plating, and different things like that. So all those that infrastructure already exists for a lot of those metals. It's kind of getting your batteries into that process that makes it kind of that circular economy of the battery itself. So you look at producing the battery, that's green and sustainable, but where did you get your metals from, and how can you take the batteries you built today and then break them down into through the recycling process into smaller chunks, bits and pieces, and hopefully through a low energy process recycle those bits and pieces back into new batteries, kind of creating a nice circle of operations there. And there's a couple of different ways you can do that with different metals, and it's nice with nickel and zinc is you can do it through a chemical process. You don't actually need to have a large smelting facility to process those into new battery grade materials. So that circularity I think is important to look at in batteries itself, but also in all aspects of the data center. As we procure all this equipment, UPS, HVAC, and all that, we look at our scope 3 emissions, or what are our suppliers bringing into your own greenhouse gases and your own sustainability story. How can we help them, our suppliers, reduce their emissions, and also help the data center customers through our own processes make their story better along the way? I think is an interesting aspect. And I know you guys have been working very, very hard on that yourselves.
Yeah, we do. And so, it's interesting. so when I look at the overall greenhouse gas emissions or equivalent greenhouse gas emissions for Schneider Electric, interestingly enough, so when we divide this in scope 1, 2, and 3, right? Scope 1, the self-generated emissions. Scope 2 is the energy we are procuring, let's say in our case, for manufacturing and operations and so forth. And then scope 3, it's all the supply chain, which is of course upstream. That's us sourcing, raw materials or subcomponents, or perhaps a battery solution, to be then, integrated together with the UPS. So it's all upstream scope 3. And then when we, have these finished goods, and now we actually sell it and deliver it, to our data center customers. So that's like downstream scope 3 emissions. And for Schneider Electric, our entire greenhouse gas emissions profile, which is, by the way, in 2022, it was about 61 million tons of CO2 equivalent. So that included scope 1, 2, and 3. And interesting enough, scope 1 and 2 is less than 1% of the entire greenhouse gas emissions profile for Schneider Electric. So 99+% is all in scope 3 in the supply chain, of which about 14% is upstream. So that means, all the materials and the components and subcomponents we are sourcing. So therefore, it's a really critical component. So in evaluating how can we, reduce the carbon emissions associated with all the products and services we are acquiring to then build and, manufacturing a product and a service, which we then ultimately sell by the end of the day to the data center industry and others. And then so we have initiated a zero carbon project with our top 1,000 suppliers. Not mandating, but kind of mandating, encouraging them, so to speak.
I like
they have to reduce. Sorry.
I like encouraging.
Yeah.
Sounds good.
Well, it's a little bit of an encouragement with a stick, right? So anyhow, so the objective of this zero carbon project is that our top 1,000 suppliers need to reduce their carbon emissions by 50% by 2025. For us to continue sourcing the materials and components and subcomponents from them. So therefore, whatever carbon reductions they are able to achieve, by 50% by 2025, that ultimately makes it a more sustainable solution, which then, when we sell it to our customers, in its operation for the next 10, 15, 20 years, ultimately has a big impact on the overall scope 3 emissions. So we're working on various components. One is, greening up the supply chain from our suppliers. And then, in our own design of our products, including the integration of technologies such as yours, we're looking at how can we implement sustainability in the design of the product, make it more efficient, less carbon intensive, easier to recycle at the end of the day. So we, for example, issue these environmental product declarations with, about 75 to 80% of all of our products, which they all have a green premium. That's what we call it. It's a Schneider label, which indicates, like different components in terms of like the materials that have been used, the take back programs, the efficiency of the programs, the extended life of it, and the minimization of any kind of hazardous materials in that. So it's part of the design. So combining the reduction on the supply chain, the design for sustainability in the creation of solutions and products, that has a huge impact on reducing the overall carbon emission, and it helps us to get to our science-based target initiative objectives, to be net zero in our own operations by 2030, and then the entire supply chain by 2040 and 2050, with offsets and without offsets respectively. So I think that is really critical that the vendors and partners and suppliers we work with, to have a clear mandate as to what the carbon impact needs to be and how it needs to be reduced. And one of the things what we identified is, like, when we set up these initial goals and objectives, many of our suppliers had no clear plan on even how to begin this journey, right? Reducing their carbon emissions. So because of all the work we've done and the leadership role we have in this regard, we actually created educational programs for our suppliers, and we helped them, and we actually audited them, and then we also asked them to, once you're on this journey, how can we ensure that what you say is actually really true. And one of the things to do that is because, we don't have Schneider Electric auditors, to go to our top 1,000 suppliers on a quarterly or annual basis to verify if that's, the information they provide is actually really accurate. So therefore, we ask them to disclose the process and the progress they are making on their journey. So therefore, it creates a public accountability. I think about it, it's similar to, like our tax returns, right? So, I can write on this piece of paper whatever I want, right? So, but hopefully it's true. Now, if I disclose it, right, and all of a sudden, now it's a different layer of accountability instead of hoping I will never get audited by the IRS, right? So therefore, being able to disclose the journey, the progress, the improvements, that actually helps create more accurate and more accountability in the supply chain. And that's, elements and things we're looking at our suppliers, including like, ZincFive.
A quick question from me, sorry to interject, I've been enjoying the conversation from the sides, but in terms of those measurements and in terms of that reporting, I just wanted to touch upon metrics as well. What in particular are you looking at to hold these companies accountable?
Are you referring to me right now, Alex? Yeah. So I think there's when I look at metrics, there's two different kind of elements to it, right? So one is the International Standards Organization, ISO, they have created a guide to environmental management system, and they have these general guidelines. It's ISO 14,000, and then there's different elements, within that, from ISO 14001 to 14024, and there's all different ones. They're all related to clearly outlining, how do you measure, how do you disclose, and how do you report on those kind of metrics and sustainability elements. And this is specifically true for manufacturing, and supply chain. So I think that's a very good framework, to actually have a international accepted framework or guidelines that clearly stipulate, as to how it needs to be done, and then therefore we can measure against the same kind of framework, against the same kind of standards. So that's one thing about the metrics on the supply chain side, so to speak, in the manufacturing part. And then I'm also thinking about metrics in terms of our customers, our clients, the data center customers. Schneider Electric, we recently released version number 2 of white paper 67, which is an environmental guide to sustainability in the data center, where we propose a framework which includes 5 different vectors. The first one is efficiency, because the greenest electron is the one we don't even need, right? So it doesn't need, it's not being consumed, so therefore it doesn't need to be generated, transmitted, distributed, switched, measured, protected, maintained, paid for, all the things. So the best part, or one of the best parts in terms of improving sustainability, is driving efficiency. And I know the data center industry has done a tremendous job in the last decade plus, in terms of creating this PUE, this power utilization effectiveness, and driving efficiency, sometimes at the cost of some other vectors in this metric we're proposing, which is, for example, water usage, right? So the more water I evaporate, so now I have an efficient cooling methodology, which doesn't require electricity, so to speak, to run a compressor. And at the same time, we see it in certain regions where, groundwater is being depleted because billions of gallons of water are being used, for cooling. And now we see the industry is shifting toward, closed loop chilled water systems and other technologies in order to minimize the effect of the water we use. So that's the second vector. The third one is actually greenhouse gas emissions, and that includes exactly scope 1, scope 2, and scope 3, right? So including the supply chain, the energy, where's the energy coming from? Is it coming from a coal plant? Is it coming from a renewable resource? What is the on-site power, the backup generation, batteries, diesels or fossil fuels and so forth. That's a third vector. The fourth vector is waste. How much waste are we creating from construction to maintain, operate, IT equipment, everything, right? So how much of this stuff ends up in a landfill? So what's the impact on that? And then the last one, the fifth one is the impact on land and ecosystem itself. So when you think about in the United States, we're building data centers low and wide, and then other areas like in Singapore, whatever, you build them small but tall, right? Multiple stories. So what's the impact on the environment itself for the data center infrastructure? And in these 5 vectors and these 5 elements, we actually have 28 key performance indicators, throughout this entire framework. And then we don't expect, and it would be foolish if a data center company or operation, would like to, embark on this journey towards sustainability, to adopt all of those 28 metrics. I mean, this is like, that would be a lot. So therefore, they divide it into beginning of the journey. So there's a subset of those, the most critical ones, the most relevant ones, and then the middle one, and then the leading ones, and we see, for example, the hyperscalers, the Googles, the Amazons, the Facebooks and Apples and Microsofts and so forth. They are really putting a lot of emphasis, and they're further along on this journey, right, than many other data center operators. However, we see that more and more are catching up, and sustainability is not a nice to have, but it's really almost mandatory for various reasons, whether it's for financial reporting, for accounting, for financing debt, for being more competitive. There's all sorts of different reasons as to why sustainability, and not to forget, we have a responsibility for the generations to come, right? So we just want to be as sustainable as we can be. And ultimately, the way I'm looking at it's like data center net zero 20. Pick a number, right? Pick a year. That's what we should aim for. And I think, companies like ZincFive, who are actively looking for, let's call it a better mousetrap, a more sustainable mousetrap, more value, more beneficial. So I think these are great technologies, great efforts, to help us on this journey, all collectively together.
I think you summed it up very well, kind of all the different things you guys are doing. And I think the important thing is that no matter what company you're part of in this industry, we're all on this journey together as as the human race. But every company is at a different stage, and we can't take every aspect of it and try to get to the end without taking the baby steps at the beginning. So I think even at ZincFive, we realized our battery technology was potentially greener, more sustainable than a lot of the other battery technologies. So we had a good place to start, and then through product development and things like that, just talking with customers and finding out different pain points of their own on their designs. Because when you think of efficiency of the data center, that's a very easy to quantify cost per month on your electrical usage. And you think about that's why I think we kind of started first. So it's an easy checkbox. Like, if we can become more efficient, we're going to save a lot of money. And I think as we look at the total cost of ownership of building these facilities, as you mentioned, if we can make them more efficient, but also if we can shrink their footprint, if we can reduce the amount of structures that we have to build or the size of those structures, we minimize our land impact. We buy less stuff, we consume less concrete, less steel, all the different things that are potentially bigger chunks of our greenhouse gas footprint. So when we look at what we can do to just make ourselves more sustainable, I think a lot of people are looking at different technologies, because UPSs have become so efficient. I think some of your UPSs are up there in 98, 99% efficient in various operational modes, and it's so impressive. Then you look at the cooling systems, as you mentioned, we focus so much on that, but also now people are starting to look at the water usage of those cooling systems. And a lot of that is, especially when we look at the UPS system as a whole, with the UPS batteries, the switchgear around it, especially as people are going into modular and containerized and really almost tremendous 80% of large colocation and cloud facilities are all being built modularly today. That the cooling requirements of the UPS are significantly higher than batteries. So the batteries traditionally have been kind of holding back on the efficiency potential of the modular data center build. So with technologies like nickel zinc, where we can operate at higher temperatures and with smaller footprints than even your traditional lithium ion solutions, we can really reduce the amount of footprint of the battery itself, which shrinks the size of the container that's housing that. And all these things kind of start adding together. So as we look at trying to become more sustainable, even though we're building larger and larger facilities, every little aspect of that facility, we can reduce the size of, if we have a 100 megawatt facility and you have 50, modular UPS buildings outside of that facility, and hopefully they're stacked on top of each other so you can get more space utilization there. But if you can shrink each one of those by a foot, you're able to save a significant amount of material. And I always think back to whenever I was a kid, and reduce, reuse, recycle was always kind of the mantra of the green movement at the time. Was if we can reduce the amount of space or of components going in, and then obviously recycling it at end of life is key. So using materials that are easily recyclable, and I think the EU directives on battery initiative are really helping to drive that, create that circularity of that. If you bring a battery into the EU, you're going to eventually have to take that battery back, whether it's yourself or have a process for that. I think it's because that's what people are looking for in general. Is they
So
want
Aaron,
everybody thinking about these circularity. Yeah, go ahead, Carsten.
So you said like you can, okay, number one, your battery solution is smaller in footprint in comparison to lithium ion, and you can operate at a higher temperature. So how much smaller is it? Is it 10%? Is it 50%? I don't know. And then from an operating temperatures perspective, how does it compare? How you can operate your battery solution versus, let's say, a lithium ion battery solution or VRLA battery?
Yeah, I think the world was used to the 77 degrees, or what's that, 20, 25 C,
24-ish, yeah, whatever.
yeah, plus or minus one. That lead acid brought about. So most of originally facilities were designed around that specific temperature. Lithium could go a little bit hotter, but then you don't want to drive them too hot because there's different things that can go on. Life expectancy, but also you get you increase potentials of thermal runaway risks and safety risks if you go on higher temperatures. So with nickel zinc, we have an inherently long life solution, with 15-year design life, 10-year full warranty. So when you look at your operation, we designed our warranty around 35 degrees C of ambient, and with excursions up to 50 degrees C for up to 5% of the life of the battery.
That's like 100 degrees Fahrenheit-ish, right?
Yeah, absolutely. I think 35 is like equivalent to about 90, 92, 95 F, and then 40 is 104. So 50 is about 122, I think, somewhere around there maybe. But you think about the climate change as a whole, and we're designing these facilities. The less cooling you can provide, and especially in a modular containerized data center, is you're saving a significant amount of energy every year, for that 20-year design life of that build. So if you can maintain your battery in a hotter environment and still maintain a long life, then you're going to save significant amounts of money, especially as you look at the ambient environments changing. What's the max temperature that we're seeing in different areas? And it seems to be spiking and increasing higher and higher. So it's really nice to be able to design your data center to operate at a higher temperature, and also not have to worry about, well, what if it goes up a little bit beyond that? And then you don't have to worry about voiding warranty. So all these things lead into the efficiency of operation, allows you to use more free cooling with your battery solution. And then, the aspect of saving footprint. I mean, we recently launched a new battery cabinet, and what we're seeing is, because we want to reduce the cabinet counts and the size of the battery installation with UPSs, we really wanted to increase our power density of our battery and make it so that we can have an even smaller footprint, less cabinets, less components, amplifying our green story, and still be able to support, as the data center keeps on getting bigger and bigger, the 1.5 megawatt UPSs, 2 megawatt UPSs, really the megawatt plus, with less cabinets. So we recently launched what we call our BC2 500, which is a smaller number of cabinets to support these larger UPS systems. So where previously we were able to offer maybe 33% smaller footprint than lithium ion, by increasing the power density of our cabinets, we can now shrink, get as small as 50% of the lithium ion solution, which is already potentially 40 or 50% smaller than a lead acid solution. So all these lead to significant footprint savings and decrease the amount of stuff that we have to integrate with our batteries, especially because, I mean, the industry as a whole is looking at run times, and it's not the 15-minute run times of the past anymore, 20-minute, 30-minute. We're getting a lot of most customers that have 5-minute requirements today, but a lot of customers are migrating to 3 or even 2-minute and 1-minute end of life requirements, so that if you have a high power density battery, you can reduce the amount of cabinets and not have to oversize your solution, again saving on a lot of efficiency gains at the site.
Yeah, so that, to me, that fits perfectly in those metrics you mentioned, Alex, about efficiency, number one, right? So then I also think about the impact on land overall, because if my electrical room is becoming smaller by X%, it's less concrete, less steel, less material, less labor, there's a lot of benefits to that, and perhaps the waste is also less, right? So when I think about packaging material, for a big battery solution versus the package material for a smaller battery solution, physically smaller solution. So there's different contributors to a greater sustainability through your solution. Am I seeing this right? Yeah,
absolutely. I think that's really sums up a lot of our value proposition. But you think of the sustainability aspect is great, but also all these reductions, they have very big financial incentives as well from the customer. So that always helps. And less stuff they have to procure, the cheaper their data center build becomes. And as they're all, everyone's always trying to compete with each other, for less dollars per megawatt of compute power, and they're trying to achieve sustainability. We don't want them to be at odds with each other. I think that's always going to be a benefit to the customer if we can do something in a more sustainable manner, but also saving costs and operate more efficiently from all the financial setups, and it makes decision to be more sustainable easier.
Yeah, it would be really interesting for us to see, since we're providing a lot of UPS technology with batteries, attached to it, how, from a sustainability perspective, the nickel zinc solution from ZincFive, actually would stack up. Because one of the things we do in our products, we provide, I mentioned earlier, these environmental product disclosure, and it includes a life cycle assessment, and it also what we publish and have available on our website is these PEPs, this product environmental profile, which is part of the life cycle assessment. And there we, provide information in terms of what's the recyclability content of this solution, right? So if we can increase this, because I'm thinking about, the SEC, the Security Exchange Commission, for the last, I think, 18 months or so, they try to implement a rule that companies need to disclose, their sustainability information, and they're still struggling over whether they should include or exclude Scope 3, which, the example I gave earlier with Schneider Electric, is 99%, right?
Yep,
so,
absolutely.
and Scope 1 and Scope 2 is so little. But then at the same time, the state of California And also in Europe, we see this, they have these corporate sustainability reporting directives, which has been in California already been signed into law, and yet they're still working out some details. And it's requiring that companies who do more globally, any company who makes more than $1 billion in revenue, which Schneider Electric certainly qualifies for that, if they want to do business in California, they actually have to report on their scope 1 and scope 2 by 2026 and scope 3 by 2023. And then if you don't, then there's penalties associated with that. So this could be like $500,000, on these Senate bills, 253, which kind of requires those public and private companies, over $1 billion in revenue globally, doing business in California, to disclose this information. So therefore, I think, we are on the right track, because what we do with all of this, when we say we disclose, it doesn't mean we're good or bad. So when I think about, hey, if I'm disclosing how many miles per gallon am I getting in this car, let's say it's 30 miles a gallon. Well, now we know 30 is actually not so bad, right? But if I have a truck, and it's like 12 gallons, miles per gallon, then it's not so good. And I think collectively in the industry, we're establishing our baselines right now. And once we have, and this is where these metrics can be really helpful. So now once we've established baselines, so then we can now start seeing like, okay, now I can make incremental improvements toward my overall, the net zero data center of the future. And I think that's going to be really interesting to see how the nickel zinc and the ZincFive solution fits into this whole kind of overall bigger picture. And sometimes I think, it might be a small portion, but every little bit counts, right? So I think that's the key component. We need to address the sustainability solution or challenge, in the data center industry collectively amongst various disciplines, including the batteries, including the UPSs, including the cement, including the steel, including whatever, the IT equipment and everything, right? So, but we all need to look at all these different components and bring them all together, because then ultimately, I think collectively, we're actually able to get to this closer net zero data center of the future.
I had a very quick question. I'm conscious we've only got 5 minutes or so left. It's been fascinating to listen to. But Aaron, you've spoken a lot about looking upstream, looking downstream, and obviously optimizing your current tech stack. But I'm keen to understand, from the battery perspective, are there any kind of common misconceptions, any questions that you get time and time again, things that people overlook?
I think just in general on the sustainability of the battery itself, I mean, that's the first place to look. But I don't think everybody's thinking about as much of the impact as it means to the facility itself on the footprint and the design of how you integrate that battery with the UPS systems. So I mentioned we kind of had just launched the BC2 500, and we look at, traditionally we offered 4 cabinets per megawatt, which was industry leading on our footprint, and would provide a 5-minute end of life solution. With our new cabinet, we're able to reduce that to 3 cabinets per megawatt, and still offering a great, safe, sustainable solution. But we've just knocked off I guess 25% of the megawatt, but now almost 33% reduction in that sustainability of that solution, not by changing what we're building, what we're making, by just optimizing the solution to the data center and what customers really truly need and want. So there's a lot of things that we can do, and I think just kind of back to the metric side of it, I think that's what the industry needs to be looking at, is as we quantify not just the battery being, we check the boxes on a sustainable battery, but every aspect of it we need to be looking at and seeing how we can reduce all of our scope 1, 2, and 3 emissions from these facilities, but also reduce our water consumption, reduce our volatile organic compounds, and our land usage as well for the data center industry. And I think without great metrics, it becomes very hard for someone to make all the right decisions and see how they actually affect the data center itself and overall operation. Because I think that metric aspect is key. And PUE was a very great. I mean, as soon as everybody started talking about PUE, we saw dramatic reductions quickly because it was a very easy metric to meet. And I think as we look at sustainability on a whole, the easier it is to quantify our metrics and make them standard across the industry, the faster I think we'll see them being optimized and met, and then people almost competing with each other to be more and more sustainable than everybody else. And I think will quickly lead us to where we need to be. And that's not the end of the journey. That's the starting point, and also maybe the early points of the journey. We still have a long way to go to truly be sustainable in this industry.
I like what Aaron was saying, Alex, about the misconceptions. So traditionally, and there's still customers out there, they put a 15-minute battery on the UPS, right? And for whatever reason, right? So the question is like, if I have a backup generator of whatever sort, for longer duration protection in the backup system, then I have to really ask myself, well, so why do I need 15 minutes battery? So why not 10? Why not 5? Why not 4? Why not 3? So because the more I can get away with, the better. Now, at the same time, we also see that, companies thinking about the backup strategy. Do I need 24 hours of diesel backup, or 48 hours of diesel backup, So maybe I can get away with less, different availability zones, different criticality zones. Not the whole data center necessarily needs to have the same kind of backup strategy. And I think that's where battery solutions are really beneficial, because when an outage happens today in the traditional data center design, we don't know how long the outage is, right? So it might be 10 seconds, might be 10 minutes. We don't know, right? So therefore, we're going to fire up typically that diesel generator. But if I have a battery solution that can help me to bridge a short duration time, and then, based on the state of charge of the batteries, only at a certain point, I would start up my diesel generators or the other whatever generation assets I may have. So therefore, we can actually reduce the overall usage of those fossil fuel longer duration backups, and we leverage battery technology. So the more sustainable that one is, because specifically when I think about the scope 3, the embodied carbon in a battery solution, it's massive. It's massive in a lithium-ion solution. Many people don't even think about it. Misconceptions of electrical vehicles. Oh, they're emissions free. That's true when you drive it. When you charge it, it's not emission free, depending where you charge it and how you charge it. And certainly from an embodied carbons perspective, they're not carbon free. So we need to look at the overall picture. And I think, solutions like the nickel zinc, they really, really have a great place to be.
I couldn't agree with you more, Carsten.
Is that why you invited me to be here?
Absolutely. No,
Okay,
I really appreciate the comments, and I think that line of thought is really why we wanted to have these conversations and think about sustainability, because it's not just, is your battery good? Is it more sustainable? But it's industry. We need to think about, why are we doing the things we're doing, and how we can make them, our processes, our designs and everything more sustainable across the board.
Excellent.
Very cool. Very exciting.
Absolutely.
Fantastic. Gents, I'm so sorry, I'm going to have to cut you off because we have run down the clock. Next up at the top of the hour is an episode sponsored by Schneider. So I'm sure, well, you guys have done a great job of kind of teeing them up. But Aaron, fantastic introduction to batteries and to kick off the day 2 of this broadcast. Carsten, thank you so much for joining and sharing your insights as well.
Absolutely, anytime.
That's great, thank you.
To our audience, thank you very much for tuning in. As we mentioned, we'll be teeing up the next session momentarily. If you did miss anything from this episode, not to worry, it will be available on demand shortly. Of course, Aaron and the team at ZincFive would love to hear from you. So if you've got any questions, please reach out to them. We also have a few resources for you, which you can download on the screen now. But we look forward to seeing you in a few minutes. Thank you.